Hello class, these are our Algebra 2 notes for rational functions. We're looking at an introduction of rational functions. Rational functions are a polynomial, a fraction with a polynomial in the numerator and denominator. But we're looking at an intro to those and also minimizing. So here's a bunch of examples, polynomials on the top and bottom. We actually did a little mini lesson with these yesterday, just kind of a review Algebra 1 thing. So here are some formulas for cone and for cylinder. And we are looking at this kind of classic surface area problem. So our example over here is a can manufacturing company is designing a can of cat food to hold 5.5 ounces or about 163 cubic centimeters. Using the volume and surface area formulas of a cylinder, write the equation for the surface area of the can in terms of the radius r. So we want to have a surface area formula, and here's our surface area right here, but we want it to only have r and s. We don't want it to have an h in there. So we need to make a substitution for h, and that's going to come from our volume formula, where we're going to use our volume. And this is going to allow us, if we have an equation for surface area that has some like volume components in it and radius, it's going to allow us to come up with the perfect radius to use. That's going to minimize the surface area. So minimize means we want to have the least amount of surface area. And reasons we might want this, reasons for can shape, you're going to have something that looks aesthetically pleasing, right? You're going to have a can that's easy to hold, so you have to think about the size of somebody's hand. But what we're really worried about is we're worried about using less materials when we manufacture. And there's environmental reasons for that, right? Less waste, especially if you're looking at something that maybe was like plastic instead, like a water bottle. The less plastic we use, the less pollution in the environment. But a lot of times companies are really looking at minimizing the surface area because they want to use less materials, because they want to spend less money, right? It's a way to save money. So we're looking at what's easy to hold, what looks nice, but really we're after using less materials to save money. So that's the reason why we might want to minimize a can. So to do this, we're going to use our volume equation. So my volume equation, I'm going to just kind of make this so I can look at everything. My volume equation for a cylinder, because that's the shape of a can, is pi r squared h. And we know we have some information about our can of cat food. It needs to hold 163 cubic centimeters. So it makes more sense to use that, right? Because I'm going to want to talk about how big my radius should be. And if I'm working with ounces, I can't talk about centimeters. So 163. This is a literal equation. Literal equations have more than one variable in them. This literal equation has an r and an h, and I want to solve it for h. So I've got to recognize that pi r squared is being multiplied by h, and so I should divide both sides by pi r squared. So this is kind of another Algebra 1 review topic. Usually it's mostly like, hey, let's take a y equals mx plus b thing or an ax plus by equals c thing and solve and move it around for like y put in a different form. But we can use this for lots of different equations. You might also do this in science if you're looking at distance equals rate times time and you're rewriting it so it's like r equals or t equals. So here's my expression for height. All right, so set volume equal to the solution, solve equation for height, substitute the variable into the equation for the surface area. So my surface area equation is 2 pi rh plus 2 pi r squared. And so I'm going to take this entire expression and I'm going to substitute in for h. And the reason is I just want to have this like as s being a function of r only. So my h is 163 over pi r squared, and then this is plus 2 pi r squared. I only want this equation to have like my s as a variable and my r as a variable. So s is a function of r. So remember when we're multiplying fractions, we can extend this. And then we could think about how r over r squared would just be a factor of r left in the denominator. The pi's would cancel. We'd be left with 2 times 163. That's going to be 326 over r plus 2 pi r squared. So now we only have two variables. We have s and we have r, and s has been solved for, so s is just a function of r. When we put this in our graphing technology, we get this shape right here. So when we're looking at minimizing our surface area, we're looking at this point right here. And in class, we decided that was about 165, which was our minimum surface area. So we ended up with a minimum surface area of 165 centimeters squared, area squared, when, and remember this is a function of radius, so when the radius is, and if I think about where this is at on the x-axis, it's 3. So when the radius is 3 centimeters. So it looks like in order to minimize the surface area, right, use less materials when we're manufacturing to save money, the environment, we would need a radius of 3 centimeters. So then the next thing you'd want to do is check that can size and see if that's going to be easy for people to grab and hold, right, and make sure that it's going to work for that as well. So this was just a really quick example. This is a polynomial equation, right? It's what we've been talking about. 326 over r is it is rational. We've got that fraction going on there. So this is just kind of to get you thinking about all the different things we can do with rational functions in this chapter. So as always, if you need help, please make sure that you ask.